Hello viewers, today I will show you how to testify a refrigerator compressor. If you have a compressor or you have you are going to test a fridge or freezer, and freezer is not giving some kind of cooling. It's mean that either something wrong in compressor or relay or some other electronic circuit. So first of all, we assess that either it's a fault of a compressor. So to test this one, we will see its relay, and its relay must be like this way. It has 3 terminals, and there are 3 terminals. One terminal is known as a common, second is known as a starting winding point, third is running point. So how to testify? First of all, what is the running and starting? So definitely to test this one, we will use a multimeter, and we will definitely find its resistance between the terminals. Okay, let's see how does we work between common and running and starting. So definitely the resistance between common and running, it must be low, and resistance between common and starting, it must be high. So we will test that in which 2 terminal give us a high and which 2 terminals give us low with respect to common. And the resistance between running and starting, it must be very high. Okay, so there must be a 3 value of the resistances between common, running and starting. Okay, see, assume that we mark 3 signs and one we consider as a common, that is right be in a triangular downside, and either this one will be a starting, or this will be a starting, or this will be a running, or this will be a running. Without testification we cannot assess that. Okay, we are going to assess that which one is running and which one is starting depend upon the resistance value between common and this terminal, if the resistance value from this to this between this one is low, then we will mark this one, this will be a running, and this will be a common. If the resistance value here will be low, then we'll mark this one will be a running, and the second will definitely will be a starting. So when we connect common at one terminal like this way, we will find the resistance value 23. We will mark this one. In the same way, we will find out the resistance value between other 2 terminals like this way. We will connect, and we will see that the resistance value is 29. We will also assess the resistance between top 2 terminals as we connected here, and we find that the resistance value is 49. So definitely, as I mentioned, the resistance always between common and running, it must be low resistance, and resistance between common and starting, it may be high. So definitely we will mark this one is a running, and this will be a starting. So since in between running and common, why it is low? Because compressor runs for a long time, for hours, so definite resistance must be low. If it will be high, definite it will be a fault, either in manufacturer fault or either in winding fault. So definitely if a resistor is working condition, then the resistance between common and running must be low. So say here in the same way we can assess that if winding is working, or if we find the values, some kind of values in the same scenario, starting common, running common, and running to starting some values, that means winding is working and winding is okay, then we will find that it is compressor winding is okay, there is no fault in the compressor. So now we will start it without relay, since relay, if the relay is faulty, so then we will start it without relay and assess that if the compressor is working or not. To test this compressor without relay, we will connect one AC terminal here at a common play point, and one second terminal of the AC component, like either a neutral or phase. It's depend upon your options. So at a running point, but not at a starting point. We will never put it at starting point. Since we will put a starting point, it will give a power to the starting winding, but not a running point winding. Since for a long time running, we need a power at running. Starting required only for a pulse. It give a pulse to start it. So definitely we will generate a random pulse by shorting this terminal to this terminal. Right? Like we will generate a short time pulse between running and starting with a multimeter. We will connect a multimeter in this way in a series combination where we will find it in amperes. So in this way we will connect it with two probes in a series wise, and we will generate a short between these one. After this we will assess that if the compressor is running or not. If compressor winding is working fine, then it must have to be started in this configuration. So here we have connected its power supply, and we will create a small short in this way, and we see that by the sound it's working, and we can assess that its sound compressor is working fine. It has a power, it has a pressure. We see that we cannot stop its pressure. This compressor is working fine.